Hey there, physics students. Welcome back to the Rapid Review series for Honors Physics. Today, I want to dig into a little deeper of a look at the meaning of plus and minus for acceleration. So you may recall last time we talked about acceleration that we said if you're looking at a number line, left and right, motion in one dimension, and you want to know what plus and minus means for acceleration, it got complicated. Maybe it's plus because you were moving to the right and speeding up, or maybe it was plus because you're moving to the left and slowing down, or whatever. That looks kind of complicated, and it's a lot more than what we're used to seeing in, say, position or velocity, right? So how do you remember that? How do you use that? Let's try a couple methods for doing that. One is you might have to just memorize it, right? If it doesn't make sense to you, you might just have to say, if I want to know the acceleration sign of something, let me just get my picture back here. If you want to know the acceleration sign of something, you just have to figure out whether it's speeding up or slowing down, whether the velocity is positive or negative, and there's your answer. Or you could remember it like in a sentence. You could say, well, if the velocity and acceleration signs are the same, then it must be speeding up, or something like that. You have to come up with a way to memorize it if you're going to do the memorizing method, whatever works for you. Another way you could do it is use algebra. And this is really the essence of why the sign rules are what they are. It's not like somebody made it up. It just falls out of the algebra. Try different combinations. Try different combinations of initial velocity, final velocity. I here did an example where I chose arbitrarily, I chose some initial velocity that's negative, a final velocity that's negative. And when I did all the math, I found out I had positive acceleration. Okay? And this is something that was slowing down. I can see the magnitude of my velocity was reduced. Try a different few of those and convince yourself that the algebra requires the acceleration rules to be what they are, plus and minus. Here's another one. I like this. This is how I always think of it on the spot. If I have to come up quickly with an answer for which way the acceleration is, I imagine a giant magnet pulling on me, right? So it's putting a force on me. It's pulling me as if I'm a hunk of metal. And I just have to remember that the direction of the acceleration vector is going to be the same as the direction of the magnet pull. So for example, if me in that picture was moving to the right, if I was moving to the right, that magnet would be slowing me down. And if I was moving to the left, that magnet would tend to speed me up. So that I find that easy to remember. And okay, I'll dare to say it, that later we're going to learn that F equals ma. When we talk about forces and we talk about accelerations, we will see that the direction of the force is necessarily the same as the direction of the acceleration. So we'll get to that when we talk about Newton's laws. For now, let me switch to one more method proposed by one of my students. This student liked to just sketch on the side of the paper a velocity time graph that looks like the one I show here in red, and that has all of the answers in it. Because this student remembers that on a velocity time graph, the slope is acceleration, positive slope, positive acceleration, negative slope, negative acceleration. And this student also recalls that on a velocity time graph, the closer you get to zero, the slower you're going. So if you look at it, this graph contains all four cases. If you sketch this on the side of your homework or even your test paper for that matter, you can't go wrong. I'm going to leave that up for a second so you can absorb it. And then I will move on. Okay, so the thing to do with these situations, these acceleration situations, is to practice a lot and to visualize them. I have given you these links in the past. These are from the physics classroom. I will provide the links again in the comments as I post this video on YouTube. And this practice is highly recommended. You'll get very used to the sense of plus and minus if you practice with some of these things that are on offer in the physics classroom. Okay, so that's all I've got. This is all about how to remember what plus and minus means and why for acceleration.